Hi everyone, today I want to present the most trending IoT project. Title of the project is Industrial Automation using IoT. Coming to myself, Monica, in my team I am the only member. Let's go to a brief introduction about my project. Alerting systems and controlling mechanisms. In industries, they are plays a major role for alerting systems and controlling mechanisms. Why? Because basically these are the key role for any manufacturing industries and thermal power stations, whatever the basic startup of industry, any industries. As we see in the recent, there were several accidents which occurred in the industries. In NTP in 2017, last year, to NTPC railway area, there were 26 people were died due to the major issue of our temperature rise or some of the boiler gas also. Likewise, in 2012, Vizag steel plant, there was so many of people were died and loss of money. So, due to the same condition of temperature rise, not controlling support, not supporting mechanisms are not available in industries, and also world mechanisms are existing. These are the major issues, in my opinion. So for the drawbacks, I am basically electrical engineer. We want to build a new emerging technologies in the existing systems like IoT. IoT, which is the best physical network which controls all the devices through the internet. We can more easily monitor the data, whatever it is on the servers, cloud database, like that. We introduce a new mechanism like rate of change. Rate of change which gives a very quick and fast response to the maintenance engineer or supervisor, whatever in supporting authority in industries. Rate of change which gives a fast, quick and response and take the preventive measures before the incidents takes place in industries. Coming to hardware and software details which is used in my project is NI Myrio as an hardware, and main mode of detect the temperature. We can use the temperature sensor here, and also gas for the direction. We use the gas sensor. These LEDs should be for the indicators like that. Coming to the software details, we used the LabVIEW 2017 software. This is the VI we developed for our project. In the project VI, we sense the temperature by this block LM35 temperature sensor. After that, the sensing temperature is sent to this block. It is a sub VA created by me. What's ongoing in the VA, I will show you. This is the block diagram of sub VA. Whatever the temperature sensing data should be on 0 point something, we convert into some Celsius degrees. So for that we divide into some number. After that, for indication purpose, we are using this scale type indicators here. After that, we compare to some of the threshold limits. If the temperature is above or below, in between the range, it gives some indications like Boolean outputs. Up to this, we explain now. Coming to the rate of change project, rate of change. In rate of change, take some basic example like that. For example, there was a 3 temperature indications like T1, T2, T3. T1 is the initial temperature of 0 degrees. T2 is the initial temperature after the rise of temperature 25 degrees. T3 is the after the 25 some increasing temperature like for example take some 75 degrees. These are the 3 temperatures which is sensing from the sensors. The T1, T2, T3 are the temperatures changes with respect to time. So for basically 0 is the initial temperature, take it as a T1, and after that temperature will increase some 25 degrees and take it as a T2, and after the 25 degrees temperature it will increase the 75 degrees, that take it as T3. 0 to 25, take first here, 0 to 25 degrees temperature, there was a difference in the 2 temperatures. Take the difference between the 2 temperatures. After that 25 to 75 there was some differences between there was difference between 25 to 75 temperature when the rise in time. Take the difference and when compared to for both differences, compare with some threshold limit. After that, they will give some indication if the rate of change is critical or should be a normal. That is the concept of the rate of change. Here we sensing the temperature will apply some threshold limits. When compare these threshold limits, the output will give some the boolean gates. After that, we created some sub VA for the rate of change. What here I will show you. Yeah, here's the sub VA which we use the slave selects for if it is true, if it false, what's the here the difference between the two temperatures, after the difference between the two temperatures, and again difference between the both the differences, we can compare with some threshold values. Later on the rate of change, yeah, we apply here, we compare with some threshold values. Actually rate of change, we are using the rate of change word many times. Basically rate of change, the entire thing which is possible within with respect to time. Here we only 1 second. That's the main concept of the rate of change. After that, coming to the VA, which shows the output of the digital output, like we can use any messages also, like critical or normal. Is the rate of change is normal or critical? You show here. Based upon the rate of change is critical or normal, the water valve will be open or closed. It is used for the water valve open or closed in the boilers for purpose. Later then we can use some indications if the rate of change is critical or normal by using this type of string indicators like that. That's the complete VA about my project. In the VA we use the same mechanism for the gas sensors, so it gives the same critical or low normal indications, like based upon the indications we can open or close by manually, because it's a manual protection. It should be safer for the industry. This is the front panel of my project. I deploy the program into the NM area, click on run here, click. Let's see how the prototype should work. In physical case, we cannot instantly increase the temperature, so we can use the soldering rod for increasing the temperature. It's very time taking process. Let's see. Yeah, you sure that there was a LED will blink on. Let's observe it. Yeah, the red light will be glowing on. So here, coming to the front panel, we show that the temperature is nearly 23.55, nearly 24 approximately. Coming to the temperature rate of change, it's very critical. The water valve should be open. So for the preventing mechanisms, it's very useful for the alerting systems like that. In coming to this prototype, we can use another LED for the rate of change. It's very critical. It's showing like that. Yeah, coming to the gas sensor, for the LPG gas detection we use the lighter here. Let's see how it works. Yeah, there was a detection of green LED we can show here. When compared to when see the front panel how it works, let me show you. Yeah, you can see here there was a gas detector is critical and the oxygen valve automatically opens. That's the working of the gas. Coming to the future scope of the industrial automation using IoT. Basically, IoT is a very emerging technology with recent developments also. When we implement this IoT technology in any industries, which is very useful for the development of economy of the India, and also it leads to the new trends of the India. Basically, IoT, which controls mechanisms and different aspects. We've seen the examples like. We can, for example, like we can control the ACs in the different area places by remotely monitor the mobile apps like that. So another aspect is I introduced the mechanism like the rate of change. Rate of change, which is the used for the thermal power stations like boilers, in the heating mechanisms like. So expansion of these projects should be very high when going to the industries, whatever the manufacturing and thermal stations like. In different aspects, whatever the heating mechanisms is presenting there should be use of the rate of change of mechanisms. Coming to IoT, already said before that there was so many applications are there. When we integration the both of the industrial automation using IoT, in integration with that rate of change and the IoT concepts, it leads to the good new industries developments in India. Thank you for giving this opportunity for the Apita and the national instruments.